calculate inductance of a single phase system. The conductors are solid conductors. Okay, we will learn about how to calculate inductance of a single phase system if the system is having solid conductors. Assume the system, here we are having two conductors, conductor 1 and conductor 2. The distance, center to center distance of these two conductors is capital D, and the radius is small r. Both the conductors having same radius. Okay, now already we know that the internal flux linkage of a conductor, last video we will discuss, already discussed this internal flux linkage of a conductor. If anyone not having clarity on this, we can watch the previous video. We already calculated the internal flux linkage of a conductor. That value is equal to 2 into 10 power minus 7 into I, where the current of I is the flowing through the conductor. It is a go conductor, then we are taking it is plus I. It is return conductor, then here it is we taken as minus I. So plus I and minus I go on the return conductors. Therefore it becomes 1 by 2 into 10 power minus 7 into I. Next, already we discussed this one also. The external flux linkage due to current flowing through the conductor, it is 2 into 10 power minus 7 into I ln d by r. This is also how we already derived. Therefore, now the total flux linkage of a conductor, the total flux linkage of a conductor 1 due to its own current. Its own current is, what is the current flowing through the conductor? It is I. Therefore, the total flux linkage is psi 1. We are called it as psi 1. This is the flux linkage of conductor 1. Total flux linkage of conductor 1 is the internal flux linkage due to current I plus external flux linkage due to that particular current I. Okay. Therefore, what you get from this? It is 1 by 2 into 10 power minus 7 plus 2 into 10 power minus 7. Sorry, here I is there. Here also I ln d by r. Okay, this is the total flux linkage. From this equation, we can common 10 power minus 7. If we common 10 power 7, what is the remaining? 1 by 2 plus 2 ln d by r. Take 2 is also outside the bracket. What you get? 2 into 10 power minus 7 into 1 by 4 plus ln d by r. So I is there here. We also common the I, 2I. Therefore, what you get? 2 into 10 power minus 7 into I. In the bracket, it is under ln. It becomes ln d by e power minus 1 by 4 into r. Okay. Then what you get finally? It is 2 into 10 power minus 7 into I ln d by r dash, where r dash is effective radius of the conductor. It is called it as effective radius of the conductor. It is also called GMR. We will discuss later what is meant by GMR and how to calculate the GMR of a conductor. Okay, in this case R dash is also called it as GMR of the conductor. Geometric mean radius. What is that value? Here r dash equals to e power minus 1 by 4 into r. This, if you calculate with the help of calculators, e power minus 1 by 4 is equal to 0.7788 into r. This is the effective radius of the conductor. If you know the r, radius of the conductor, then we can easily calculate by multiplying 0.778 into 88. We can get effective radius of the conductor, that is r dash. Okay, now the final formula for this is flux linkage of a conductor due to its own current. The formula is 2 into 10 power minus 7 ln. This is I is there. 2 into 10 power minus 7 I ln d by r dash. Keep in mind this one. This is the current flowing through the conductor 1, that is plus I, d2 plus I. This is the amount of flux, total flux linkage of a conductor 1. Next we have to calculate, that is, okay, go to another page. Okay. This is, now we have to calculate, here we are having two conductors, conductor 1 and conductor 2. The current flowing through the conductor is I, the current flowing through the second conductor is minus I. How much flux linkage due to this current? It is 2 into 10 power minus 7 ln. Here we have to write I ln d by r dash. This is due to this current. Now the amount of the return conductor also generate the flux. That flux is also induced in the first conductor. We have to add this conductor. Therefore, this one becomes 2 into 10 power minus 7 into minus I ln. The formula becomes reverse, r dash by d. Okay. Now in this expression, this is amount of flux due to go conductor. This is amount of flux induced due to return conductor. Therefore, what you get finally, the expression becomes it is 2 into 10 power minus 7 into I ln d by r dash minus 2 into 10 power minus 7 ln r dash by d. Okay. Now we can write it as ln of x by y equals to minus of ln y by x also. Okay. Use this one here. We can get 2 into 10 power minus 7 I ln d by r dash plus 2 into 10 power minus 7 ln d by r dash. Okay. Both the terms are same. What you get finally? That is 2 into 10 power minus 7. It becomes, the 2 becomes, both the terms are same. Therefore, the total flux linkage equals to 4 into 10 power minus 7 I ln d by r dash. This is the expression for inductance for single phase system. This is inductance of a single phase system. This is inductance of a single phase system. Okay. Now, both the conductors are in parallel. Therefore, here the conductor 1 and conductor 2 both are in parallel. Therefore, both are in L. What is the total? Total is equal to L into L by L plus L. L square divided by 2L. L square get cancelled. Finally, you get L by 2. Sorry. Therefore, from this expression, we can calculate the inductance per conductor. Inductance per conductor is L single phase by 2. You can get 2 into 10 power minus 7. Sorry, here I will get cancelled. You can calculate this. Small correction here. Finally, what you get? Total flux linkage of a single phase system is 4 into 10 power minus 7 I ln d by r dash. Therefore, the flux total inductance of single phase system is psi single phase divided by I. You can get 4 into 10 power minus 7 ln d by r dash. Already we know that what is meant by r dash. R dash is effective radius of the conductor. The effective radius of the conductor. Next, here both the conductors, the conductor 1 and conductor 2, both are connected in parallel. Therefore, how much is the total inductance? The L equivalent equals to L, this is L, this is also another L. L into L by L plus L. What you get finally? L square by 2L. Here L square get cancelled, L by 2, where L is the inductance of a conductor. Therefore, the single phase system, once we know the single phase system inductance, that is 4 into 10 power minus 7 ln d by r dash Henry per meter. From that, we can calculate inductance per conductor. What is inductance per conductor? It is L single phase divided by 2. How much you get? 4 into 10 power minus 7 ln d by r dash divided by 2. You can get the L per conductor, inductance per conductor in a solid conductor is 2 into 10 power minus 7 ln d by r dash. Okay. From this, what you understand from this derivation, it is, once we know the inductance per conductor, once you know the inductance per conductor, if you know the inductance per conductor, from that we can calculate single phase inductance by multiplying inductance per conductor with 2. Okay, you can get. This is the relationship between inductance per conductor and single phase system. Here one term we have to know. In examinations, in problems, they are asking calculate loop inductance. Calculate loop inductance. What is loop inductance? Loop inductance is nothing but single phase. Okay, keep in mind we need to calculate single phase inductance. They asked about calculate inductance in a conductor. Inductance in a conductor means we have to calculate 2 into 10 power minus 7 ln d by r dash. They are asking about calculate loop inductance for single phase system. Then we have to use the formula 4 into 10 power minus 7 ln d by r dash. Okay, keep in mind that. Now we will discuss problems on this. And so many examinations they will ask about the problems on this system. Now I will explain the problem. The problem is calculate. Yeah, calculate inductance calculate inductance of a single phase system. Inductance of a single phase system having two wire system. Single phase system is a two wire system. If the distance between the conductors is 2 meters and the radius of each conductor is 1.2 centimeters. Okay, now calculate this one. Here we need to calculate inductance of a single phase system. Here we need to calculate the inductance of a single phase system. What is the formula for inductance of a single phase system? First of all, we have to write the given data, what they given. Okay, in examinations they are provide some marks for given data also. That's why first of all we have to write the given data. What they given? The distance between the conductors is 2 meters. Convert this one into centimeters. It is 200 centimeters. Keep in mind 1 meter equals to 100 centimeters. Okay, now radius of the conductor. The given radius of the conductor is 1.2 centimeters. We have to keep both the units, distance between the conductor and the radius of the conductor, both are in same units. Now we need to calculate what is the formula for inductance of a single phase system, that is 4 into 10 power minus 7 ln d by r dash. Here we need to calculate r dash also. What is the formula for r dash? R dash equals to 0.7788 into 1.2. Okay, this value is equal to 0.93456 centimeters. Then substitute in this expression, d equals to 200 and r dash equals to 0.93456. You can get the inductance is 21.46 into 10 power minus 7 Henry per meter. We can also convert this one into micro Henry per kilometer also. The value becomes 2.146 milli Henry per kilometer. Okay, this one we can write it as 2.146 into 10 power minus 6 Henry per meter. If we can write the same 146 into 10 power minus 3 Henry per kilometer, this 10 power minus 3 Henry, it is nothing but millihenry. This is the way we can express. Per kilometer is very good in examinations after calculating this. Okay, now we will discuss another problem. We can solve this problem. Okay, I will give the problem, calculate this one. Okay, it is very good to you. The problem is calculate loop inductance. Calculate loop inductance of a single phase line with two parallel conductors spaced 3.5 meters apart, and the diameter of each conductor, the diameter of each conductor is 1.5 centimeters. I will give the given data and we have to calculate the solution. Okay, the distance between the conductors is 3.5 meters, then it becomes 350 centimeters, and in previous problem they given directly radius, now it is diameter equal to 1.5 centimeters, therefore radius of the conductor is d by 2, it is 0.75 centimeters. Calculate r dash, that is 0.7788 into 0.75. And for what is the formula for loop inductance? The loop inductance L single phase equals to 4 into 10 power minus 7 ln d by r dash. Okay, substitute the d value here and r dash value here. Substitute this d value here and r dash value here. You can get this value is 2.558 millihenry per kilometer r. Please scratch it. Okay. Sorry. Now, okay, we have to move to another problem. This is also very important problem. In so many examinations, they will ask about this type of problems. Okay. The question is, calculate inductance of a single phase circuit comprising of two parallel conductors of 6 mm in dia and spaced 1 meter apart. If here condition are, if the material of the conductor, first case is copper and second case is aluminum. First case is copper and second case is aluminum. How we can solve this problem? Okay, how we can solve this problem? And also the given one condition, they provide aluminum with a relative permeability of 50. Okay, they mention μr value 50. Okay, how we can solve this type of problems? It is also one of the important question on single phase system. First of all, we have to write the given data. What the given? The diameter of the conductor. The diameter of the conductor is 6 mm. Therefore, radius is 3 mm. Now, the distance between the conductors is 1 meter. Okay, it is very easy, convenient to change the units of radius into meters, mm to meter. We know that 1 centimeter equals to 10 mm, 1 meter equals to 100 centimeters. Therefore, from 1 meter equals to 100,000 mm. Therefore, 1 mm equals to 10 power minus 3 meters. Use this here. How much you get? It is 3 into 10 power minus 3 meters. Okay, change this mm to meter. Now we can calculate the inductance of first copper conductor. The formula for this one is, the formula for this single phase system is, it is per conductor. Okay, we need to calculate per conductor. It is 10 into 10 power minus 7 mu r plus 4 ln d by r dash. This is the formula for internal. We have to add internal and external. Okay, this is the formula for single phase. Then have to substitute the values of copper. If it is a copper conductor, first case, copper conductor, mu r equal to 1. Therefore, substitute mu r equal to 1. What you get? Plus 4 ln 1 by 3 into 10 power minus 3. How much you get? Calculate this value. We can get this value is equals to 2.424 Henry per meter. Henry per meter. Now, if the conductor is aluminum conductor, the conductor, second case, if it is a aluminum conductor, they given mu r equals to 50. Substitute mu r equal to 50. Therefore, L single phase equals to 10 power minus 7 in the place of mu r, 4 ln d by r dash. Therefore, substitute this 10 power minus 7, 50 plus 4 ln 1 by 3 into 10 power minus 3. How much you get? This value equals to 7.324 millihenry per kilometer. It is also millihenry per kilometer. Henry per kilometer. Okay. What you observe from this example is, if mu r value is more, the inductance value is also increases. Keep in mind. Okay, this is the way we will solve this problem. Next, we will take another problem, that is, if the distance is different, we will change the distance, then how we can calculate what is the effect on inductance. Yeah, this is also one of the type of problem in this single phase system, that is, determine the inductance of single phase 25 Hz 16 kilometer. They mention the length of the transmission system, it is 16 kilometer long transmission line. Which consists of a pair of conductors. Consists of a pair of conductors means what? Here we are having two conductors. Pair of conductors of diameter is 1.2 centimeters and spaced here they given the two cases. One is 1.2 meters and second case it is 60 centimeters. Here D is different. Okay, now you can go through this. First of all, first write the given data. What they given. What they want to calculate. Here one thing, they want to calculate inductive reactance. Okay, change this one. I have to calculate the inductive reactance. reactance. Means what is inductive reactance? Inductive reactance is XL. We know the formula 2 pi f into L. The given frequency 25 Hz, and we know the formula to calculate L. Okay. Now go to the given data. The given frequency is 25 Hz. Length of the line, length equals to 16 kilometers. What you have to calculate? XL we have to calculate. We know the formula for XL. XL equals to 2 pi f L. They already given f, and here L is inductance of the inductance of single phase system. How we can calculate inductance of single phase system? Case 1, the distance between the conductors is 1.2 meters, and what they given? Diameter of the conductor is 1.2 centimeters. Therefore we have to calculate radius of the conductor, r equals to 0.6 centimeters. Okay, go for first case, that is the distance is 1.2 meter. This one comes 120 centimeters. Now what is the formula for inductance for single phase system? Inductance for single phase system is 4 into 10 power minus 7 ln d by r dash. Substitute here d and r dash values. Ln d equal to 120 centimeters, and where r dash equals to 0.7788 into 0.6. Therefore, here no need to write the centimeters. It is 0.7788 into 0.6 Henry per meter. If you calculate this, how much you get? It is 2.2 millihenry per kilometer. Per kilometer, observe here, this is the inductance of a single phase system per kilometer. What the given length? The length of the transmission system is 16 kilometers. Therefore, multiply this with 16, then we can get the transmission line inductance. The transmission line inductance is 2.2 into 16. How much you get? 35.52 millihenry. 35.52 millihenry, that is the inductance. Therefore, we can calculate XL equals to 2 pi f L, that is 2 pi into frequency is 25, inductance is 35.52 into 10 power minus 3. How much you get if you calculate with the help of calculator? How much you get? This value is equals to 5.579 ohm. We represent the XL in ohm. This is for case 1. In case 2, what is the value of D? Here now D equals to 60 centimeters. Then the formula, single phase system is loop inductance, that is 4 into 10 power minus 7 ln d by r dash. This one is equals to 4 into 10 power minus 7 ln 60 divided by r dash value is 0.7788 into 0.6. How much you get this inductance value? This inductance value is 1.942 millihenry per kilometer. If you multiply with the 16, then it becomes 16 kilometers. That value equals to 31.07 millihenry per 16 kilometers. So this is for 16 kilometers. Therefore, the XL value equals to, what is the XL value? 2 pi FL, that is 2 into pi into 25 into 31.07 into 10 power minus 3. How much you get? 4.88 ohm. Observe the values here. If distance is less, the inductance value is inductive reactance value is less. Therefore, XL value is directly proportional to D. D is increases, XL value is increases, then the drop is more, voltage drop is more, your percentage regulation is more, then it is not an effective system. If distance is less, XL value is less, then drop is less, then regulation is less, then it is a very good transmission system. Okay. In any competitive exams, they will ask if the distance between the conductor increases, what about the regulation? Regulation is also increases. If regulation is increases, it is not a good system. Okay. I think you understand what is meant by single phase transmission system inductance calculation, derivation part and problems related to single phase inductance calculation. Thank you.